applied as droplets over spearfishing and as frost over NHL because we're Canadians, and so it's like, I think it's in our constitution that we have to include hockey in our research. So, in addition to being customized to be consistent with the visual style, theme, or genre of the game, the graphical effects are also consistent with current abstract in-game visualizations that players are already familiar with using. And for example, tunnel vision representing poor in-game health, for example, like this in Call of Duty, or we see a lot of discrete effects like blood splatter representing a hit in a first-person shooter, which I'm not showing because I just realized before this that kids are invited to this conference, and so I should be careful with what kind of game images I show. So finally, here's the animated sprite effect displayed as spiders over Crisis and particles over NetRumble. And I just finally want to mention one more thing at this point, that the textures are multidimensional, so there are lots of parameters that can be adjusted to provide feedback. So although we use the amount of graphics on the screen to obscure more of the screen as feedback, you can do a lot of different things. For example, the spiders can move at different speeds to different locations, be different sizes. These particles can have different colors or spawn points. They can even have different physics applied to them, like how they respond to gravity. So the system's really flexible and can produce a lot of different visual effects. And I'll also note for the nerds in the audience that we use pixel shaders so that the processing is all done on the graphics card and doesn't slow down the underlying game. All right, so I've shown you that the kind of visualizations that we can build with our system. And by creating this biofeedback game system that works with off-the-shelf games, we've solved the problem of the lack of difficulty, the problems of the difficulty of creating a game, the lack of strategic depth in games, and the lack of choice that users have over the game genre. And our system also addresses this final problem of users wanting to choose which system they want to train. Because our system decouples physiological sensing in the biofeedback loop from gameplay. So users can choose what they want to train, for example, relaxation or focus, separately from their game choice. So any of these games can be played with any of these sensors. A user can choose to play Plants vs. Zombies to train stress or Bejeweled to train focus. Any off-the-shelf game can be used to train any state that can be sensed as long as the device has a software development kit. So we created this system that solves lots of problems with biofeedback games, and we're doing a bunch of different tests on the efficacy of the system in different scenarios and with different populations. Which leads me back to the motivation I laid out at the beginning of the talk, that children with FASD have trouble with their ability to focus and concentrate, and biofeedback training has been shown to be effective for kids with ADHD. Also, biofeedback training has reduced the differences in the EEG that you can sample between children that have ADHD and normative databases. So there's some evidence that it can be a successful training mechanism.